Hello everyone, this video is on group of permutations. A group of permutation is a part of symmetric groups. A group consists of a set and an operation defined on the set. The group of permutations consists of a set of permutations and the binary operation is the permutation multiplication. Permutations and permutation multiplication. Next, we define permutations. We give a formal definition of permutation. Permutation means arrangement of objects. So let S be the collection of three objects, first object, second object and third object. Then the arrangement such that 1, 2, 3, first object, second object and third object is a permutation of S. Likewise, the arrangement second object in the first position, third object in the second position and the first object in the third position is another permutation of S. Now consider the permutation 2, 3, 1. In this permutation, first object goes to third position, second object goes to first position and the third object goes to second position. So in a permutation, in an arrangement, there seems to be a relationship between the objects and its position. Let us present this relationship in a diagram. This permutation, first object, third position, second, first position and third object takes second position. So clearly the relationship is a function. It is a function between the objects and its positions. So mathematically, a permutation is nothing but a function. Therefore, a formal definition of permutation is a function from S to S such that the function is both one-to-one and onto. Therefore, this permutation, this arrangement becomes this permutation as a function. Note that the arrangement is 2, 3, 1. But the permutation in terms of function is 3, 1, 2. There are many ways to define a permutation, but we prefer this way of definition because it makes us easier for the calculation. Next, we define the operation permutation multiplication. Permutations are functions and therefore permutation multiplication is nothing but a function composition. Let S be a collection of three objects 1, 2, 3 and let these two are the permutations of S. Formally they are known by the name rho 1 and rho 2. Now rho 1 and rho 2 are nothing but a bijective function from S to S. Now the permutation multiplication, the multiplication between these two permutations of S is nothing but a function composition of rho 1 of rho 2. Now let us execute this function composition rho 1 of rho 2. From definition, we execute rho 2 first, then rho 1. We have from our earlier definition, first row is the row of objects and second row is the row of position. Therefore, rho 2 takes third object to second position and rho 1 takes the object at second position to the third position. That is, third object to second position and the second object to the third position. And altogether we have third object goes to third position. Third object goes to third position. We have written it here. Third object goes to second position by rho 2, then by rho 1 the second object goes to third position. Therefore, the operation rho 1 of rho 2 takes third object to third position. And in a similar manner, second object goes to first position by rho 2, then by rho 1 this object at first position goes to second position. Therefore, second object goes to second position and likewise first object goes to first position by the operation rho 1 of rho 2. So we are left with the permutation 1 2 3 1 2 3. This permutation is formally known as rho naught. Therefore we have rho 1 of rho 2 is equals to rho naught. This is the permutation multiplication. A set of permutations of a set under the operation of permutation multiplication forms a group. The proof is very easy and straightforward. A permutation is nothing but a bijective function. Therefore, the composition of two bijective functions is again a bijective function from S to S. Therefore, the set of permutations are closed. Second, for associative, the operation permutation multiplication is a function composition and the operation of function composition is associative. Therefore, this set follows the associative axiom. Third, the set of permutations has a identity function. That identity function works as a identity permutation for this set. And finally, permutations are bijective function from S to S. A bijective function has a inverse function. Therefore, every permutation has a inverse permutation as inverse element. So, a set of permutations of a set under the operation of permutation multiplication, it satisfies all the four axioms of a group, therefore forms a group.